So welcome to our Wednesday night meeting. This is the third Wednesday of the month for the Boston.NET Architecture Group. We've been meeting now for actually a little over 18 years. This is crazy to think about that this started over 18 years ago, although at the time we started, it was called the Boston Code Brew. And then a few years later, we renamed it to the Boston.NET Architecture Group. And it's been that ever since. And we've met a lot of different places in person, at Microsoft offices mostly, but at other places as well. But since 2020, we've been meeting virtually and online, and we're doing this again tonight. And really glad to have everyone here. Our guest tonight is Steve Smith. He's going to be talking to us about a topic that's been of great interest to me over the years as a developer, as an architect, and always thinking about clean architecture and how do I do the work more efficiently if I can. And so without further ado, I'm going to turn it over to you, Steve. And again, thank you for joining us. Really appreciate it.
Yeah, thanks for having me. Hey, everybody. Nice to see you. If you're watching this on the recording, thanks for watching. Yeah, today we're going to be talking about clean architecture with ASP NET Core. The current latest version is version 7. My name is Steve Smith. If you're looking for me online, I go by Ardalis because Steve Smith is one of the more generic names out there, and it's really hard to get that username someplace. So you'll find me on GitHub or Twitter or whatever as Ardalis. I also work for a small consulting company called Nimble Pros, and we help companies write better code faster. Currently doing a lot of Azure and cloud migration of old .NET stuff and moving it to .NET Core, .NET 7 for various clients. If you're interested in this topic, you may also find some of these other things interesting. If you're trying to use clean architecture, it's likely that you also want to be using domain-driven design. They go together really well. So if you're doing domain-driven design, you probably want to be using something like clean architecture, or at least something that facilitates having a loosely coupled system. And I've found that clean architecture works well with that. Same thing with microservices. If you're starting to look at microservices or building microservices, clean architecture can work well with that too, as well as, a lot of concepts from domain-driven design. So I have a popular course on Pluralsight on domain-driven design that I did with Julie Lerman. And you can check that out if you're interested. Also have some free resources. I help maintain some of Microsoft's architectural samples, including the eShop on Web sample, which uses clean architecture, and we'll take a look at that tonight a little bit as well. And there's a free ebook that I wrote that goes with that. It's like a 100-page PDF you can read and kind of get some of the basics of this stuff too. I do mentoring for developers too through DevBetter, and some of the folks in the audience are from my group actually. All right, so I like to get started with questions, and a lot of times I have prepared questions. So I have a few slides that have some questions, but since we have a live audience here right now, does anybody have any questions that they want to just shout out or throw in the chat? And I'll make sure I cover them. I'll give it a second before I move on. Something you want to know about clean architecture or .NET architecture in general?
How different is .NET 7 from .NET 6? Are you finding it challenging?
That's an easy one. No, .NET 7, .NET 6 was like a super easy upgrade. Very little has changed, at least for ASP .NET Core. They did some changes in Blazor. Entity Framework has some new features, but there's not a lot that's breaking changes. So you can pretty much just take your project files and change, .NET 6 to .NET 7, and there's not a whole lot else that you need to change with that. One thing I am changing in a lot of my open source projects and client projects is using the directory properties files. That's not a .NET 7 feature necessarily. I think it was there in .NET 6 as well. But it makes it a lot easier if you have several projects in your solution. You can put all the versions of all your NuGet dependencies in one top-level file, and then that will keep them all synchronized. So you no longer have to go to many different projects and try and get all their NuGet package references to be in sync. So I found that to be very helpful. And it's, I think, been out for about 6 months or so, and it didn't have support in the tools until I think last summer. So that makes me think it might have been with .NET 7, or at least the later version of Visual Studio. But is anybody else using that, the directory packages props and directory build props files? Yeah. I'll show them to you when we get into the code.
Yeah, I
They're
think it's
handy.
Visual Studio 2022 because that's I think we're on older.NET, but VS 2022 does that.
Yep. Yeah, Evan says he's using them in a couple projects. I don't think the chat gets recorded, so if there's anything interesting in the chat, I'll just make sure to read it. Any other questions before we get started?
Thank you.
Yep, no problem. All right, well, then I will go back to my fallback questions because that's what always happens. People don't have a lot of questions until you start. So we're going to talk about some of the theory behind architecture. And in this case, we're mostly talking about architecture from the perspective of how we organize our code and not necessarily how we build, the distributed system. So all the stuff we're going to talk about right now is applicable to a single monolith. But that's not to say that you couldn't apply this to a microservices or message-based system where each individual microservice might itself then be organized using these same principles. All right. So the first one is, why would we want to separate an application into more modules, or in Visual Studio, we'd call them projects. And then if we are going to break it up into different projects, we don't have to, but if we are, what are some of the principles that we would want to use with that? What would make sense to determine what goes where? And then if we make some decisions about how we want to organize our code into different projects, what are the consequences? What are the trade-offs that we get? And one of the ones I'm most interested in is coupling, because it turns out that coupling is one of the things that causes a great deal of pain later on in your system if you have tight coupling to in the wrong direction, which we'll talk about. So we'll see some of the common problems associated with certain architectural approaches, certain decisions about especially the dependency direction and how that coupling comes into play. And of course, we'll talk about what is clean architecture and what are some of the problems that it is designed to overcome. And what problems does it introduce, right? Everything in architecture is trade-offs. That's the first law of architecture, is everything is a trade-off. So it's not to say that you should always use clean architecture and it's a net gain every time. There are some trade-offs. In fact, there's a fair bit of backlash these days against it in YouTube or Twitter or wherever you want to go, where people are saying, why is everybody using clean architecture when you don't need it? It's overcomplicated, it's over-engineered. Here's an example that I just did a quick search before this talk from someone on Twitter saying clean architecture has all these ports and adapters and layers of abstraction. And when I look at that with these demo apps that are showcasing it, it just makes me want to cry. And he's saying it looks over-engineered for something that's basically just a hello world demo app. And that's the challenge if you're a trainer or someone who's trying to convey an idea. You don't want to actually build an enterprise level application just to be able to show some architectural principle, right? So of course, any demo that's showing you clean architecture is going to be so small that it didn't need clean architecture, right? But that wasn't the point. The point was that you could use this on something that is going to get bigger and it continues to yield benefits. So there's often straw man arguments. There's a recent podcast episode on .NET Rocks where the guest had a little rant about clean architecture, was saying, I can't stand clean architecture because, it has like these 8 or 10 different projects that you have to put in everything. It's like, there's 3. Like there's usually exactly 3 projects that your production code would go in. It's not 8, it's not 10, it's not dozens, it's 3. So it's not as bad as some people would make out in most cases. All right, so let's talk about some guiding principles and things that we can use that are well established in the industry when we think about our architectural choices. And so this kind of helps us decide, like, how do we want to organize our code, and does it make sense to do it this way versus that way? And one of the first ones that I like is separation of concerns. And you've probably all heard of separation of concerns. The idea here is you don't let your plumbing code pollute your software. And I know my video screen right now is probably really tiny in everyone's video, but I actually have this like right here, just on the wall, because it's one of the ones that's most fundamental, most important principles that you've got. And so you really, if you think about your kitchen, right, hopefully you've organized it in such a way that your cleaning supplies are under the sink or in a closet somewhere, and your steaks and your milk are in the refrigerator, and the two don't come too close into contact most of the time. But if you look at this refrigerator and you look at it closely, you might see there's some missing separation of concerns where things are polluting one another that shouldn't be in the same place. And that idea is the same in our code. That metaphor applies. We don't want to have different levels of abstraction or different concerns commingled in the same part in our code. Different responsibilities, things like data access or persistence or infrastructure concerns like messaging or network calls or web APIs, and user interface concerns and how the user is going to actually interact with the system. Those are very, very different concerns that shouldn't usually be in the same place in the code. And so we avoid putting them in the same method, if at all possible, but we can take that further and avoid putting them in the same class, follow the single responsibility principle from Solid, and avoid having those different responsibilities mixed in the same class. And in fact, yes, it may even make sense to keep some things separated into different projects, just to make it extra sure and safe that the system is going to be not accidentally lending itself to this type of coupling that we don't want. All right, the next one is spaghetti code. And spaghetti code is this notion that if you don't have any separation of concerns, you have everything all mixed together, it makes it really hard for you to maintain that code. And if you've written code like classic ASP or a lot of script-based languages like PHP and other systems, you don't have to write spaghetti code, but a lot of these types of frameworks lend themselves to it. Even if you just do like Razor pages in modern ASP.NET Core, you could easily find yourself writing spaghetti code with lots of UI logic and HTML commingled with a bunch of business logic and data access logic all in the same Razor file. And so that's sort of the antithesis of what you want to achieve when you're following separation of concerns. You want to have all the business logic be in one place where you can easily test it and reason about it and have that be the model of the problem that you're trying to solve. And then have the way you render that to the user be a totally separate concern. And in fact, you could have different ways to render it in different environments. Could be that you have a mobile app as well as a web app, as well as a command line interface. And each one of those will have different ways of rendering the data that you're using, but they could all use the same backend business logic and model of the problem. So the big three concerns that you typically want to make sure you're keeping separate are going to be data access, your business rules, or if you're following domain-driven design, it would be your domain model, and then the user interface. And I did see, going back to where I was talking about projects, there was a comment that said Azure functions require a bit more fiddling when moving from .NET 6 to 7, but otherwise it's pretty smooth in my experience. All right, so I was answering the question Mark had about .NET 6 to 7, I guess. I don't use Azure functions very often, so that's not one I've run into, but thank you, Adrian, for the answer. All right, coming back to single responsibility principle, which I already mentioned. The idea with single responsibility is that you don't put too many things in the same place. And it plays really nicely with separation of concerns. They're very similar concepts. With single responsibility, you don't want to have more than one reason for a class to change. And so if you have a class that's doing too many things, if any one of those responsibilities changes, then hey, now you've got to change that class. And the more often you have to change a class, the more likely it is that you introduce a bug or break something, or have to make other changes to related classes that depend on it. So if you follow sort of the Unix approach to design and you make very small classes that do one thing and do them well, then you can compose those together in a modular fashion and have really rich sets of functionality in your system, but where each individual component is, not too tightly coupled to everything else, right? Each one can evolve and change independently from one another. Okay, so you generally want to avoid mixing these responsibilities because of the coupling that it introduces. By having multiple responsibilities in the same class, those responsibilities are now coupled because they're in that same class. So it's better to have lots of smaller classes generally, at least if you're going to follow the Solid principles. And so we're not going to cover all of Solid, but the dependency inversion principle is the D in Solid, and that one's very important to this architectural choice as well. The D stands for dependency inversion. And so the idea here is that you don't want to have your dependencies going from your abstractions, like your business logic, to your concrete implementation details. And so your domain model, which has things like entities and value objects and just pure classes, right? Just pure logic, nothing to do with whether you're talking to a SQL database or talking to a file system or talking to MongoDB, nothing to do with whether it's ASP.NET Core on the front end or WPF or WinForms or console, doesn't know about any of that. It's just classes, right? We don't want those classes to depend on any of those other things I just mentioned that are specific concrete implementation details. All right, so the idea is that your high-level modules should depend on abstractions, not the low-level modules. And then those low-level modules should also depend on shared abstractions. And it's important then that those abstractions themselves don't depend on details. So bringing this to C#, we want to make sure that an abstraction is typically an interface, sometimes an abstract base class. And what this means when we say an abstraction shouldn't depend on details is you wouldn't want to have a customer data access service that had a thing for fetching customers, and the return type was a SQL data reader. Because now your abstraction, which is supposed to be abstract, it's supposed to be decoupled from the implementation, is tightly coupled to SQL data reader, right? So good luck with using that to read from the file system or read from an XML file or JSON or whatever it might be. You'd have to do a lot more work to return a SQL data reader from one of those other types of data. So it's better for these abstractions to only depend on types that are in the framework. So you should be returning an enumerable or a list or an entity or something that's defined in your domain model itself. All right, so make sure that those details depend on the abstractions and not the other way around. And this makes sure that your dependencies don't flow toward low-level code, but instead they flow toward your high-level code. And when I'm talking about low versus high-level code is further away from the concrete implementation details of things that are out of process, right? If I have to wait for the user to click a button, that's an out of process thing, right? That's outside of my code. If I need to write to the file system, that's out of process, right? I have to talk to the operating system and write to the file. Whereas if I'm in an employee class that's part of my domain model, it doesn't know anything about out of process stuff. Everything it does is just in process with methods, talking to other methods, passing around variables, pure .NET C# stuff. And that's what makes it high level, not low level. All right, so we want to organize our application so that these dependencies flow toward that high level code and not away from it. A related principle is the explicit dependencies principle. Explicit dependencies principle basically says that your classes should request all their dependencies from their constructor, which makes them honest, not deceptive, right? They're not going to have a constructor that maybe doesn't take any parameters, and when you new it up and try and use it, it blows up and says, oh, I needed to talk to this file. Oh, I needed this config setting. Oh, I needed to connect to this database, right? You don't want services or classes that surprise you by having dependencies that aren't asked for in the constructor. You can think about this as like a recipe, right? Whenever you read a recipe, the first thing at the top of the recipe is a list of all the ingredients. Here's all the things you need to make this dish, right? And then there's all the details of how you're going to do it, right? So if you look in a cookbook or look online and you say, hey, there's this cool recipe, I want to make it, stop at the store, grab all the things you need, run home, turn on the oven, turn on the stove, start cooking. And halfway down, it says, okay, now add this other ingredient that wasn't in the list. Right, you're going to be pretty upset that this thing wasn't in the ingredient list. You don't have time to run to the store now. Your stuff's already halfway being cooked. Right, that's not a good surprise. Right, we don't want our classes to surprise us either. We want to make sure that whatever it is they need, they're explicitly requested through the constructor in order to create that type. That will make you a good citizen when working with dependency injection frameworks, which is how .NET 7 works and all of .NET Core before it. All the way down, right? Everything is DI based now, and in this case, DI is dependency injection as opposed to dependency inversion principle. All right, Derek has a question. He says, when applying clean architecture, does it at some point suggest that a namespace like myapp.infrastructure.tenancy be promoted to its own new tenancy project? Why or why not? Okay, so the question is, if you have a lot of different types of infrastructure concerns, you've got data access, you've got messaging, you've got file stuff, you've got email stuff, you've got tenancy, right? When would you take those and start breaking them up into their own projects instead of having one big infrastructure project that has all those things in it? I think that's mostly just a matter of taste. I don't generally break it up prematurely. If they were going to be reused between different solutions, then it might be an opportunity to create your own library for that. For instance, let's say you had your internal set of microservices that you wanted to use. And you didn't necessarily want to have to reinvent the wheel of how you're going to talk to those internal microservices for every one of your other applications, right? You could create a separate project for that, or even better, a NuGet package that had the client code for talking to your internal microservices, and then use that instead of having them be part of the generic application-specific infrastructure project for a bunch of different projects. There's probably other considerations as well where you might want to split it up. But it's been pretty rare that I've seen the infrastructure project be so big that I felt like I needed to break it up. One of the things that I see pretty often with folks that are trying to follow Solid and trying to follow some of these patterns is sort of abuse of the repository pattern. And I'll talk more about that in a little bit, but frequently I'll see their infrastructure project data access folder has tons and tons and tons of repository implementations, like literally one for every single entity in the domain model. And that could be, 100 or more. And at that point, you might be thinking, well, gosh, there's so much stuff in here that's just data access. I should probably split that up and have a data access project and have everything else be in a different one, just because it's so big with just the data access stuff. My solution template that I use and the patterns that I use prevent me from needing to do that. It's very rare that I will have more than one repository in infrastructure. And so the other things don't tend to get that big. Like I need to send email. Okay, maybe there's a couple classes. I need to call some other web APIs. Okay, there's a couple classes, right? There's not that much stuff that tends to get so large that I feel like I need to carve it out into another project. But if it does, then feel free to split it out. That there's no reason not to me, as long as you make sure it has the same dependencies that infrastructure does. And we'll talk about that in just a minute. Okay, before we talk further about coupling and dependencies, I want to talk for a minute about the difference between compile time and runtime dependencies. So in these two charts here, this is an example of what your code looks like if you don't use abstractions and you don't use dependency injection, and instead you just new up your dependencies anytime you need them. So let's say on the left, you've got some class A, maybe that's your entry point, public static void main. In there, it news up class B and calls a method. Inside that method, it news up class C and calls a method. And that's what it looks like at compile time, right? That's all those references get checked by the compiler and it makes sure they all look good. Everything's strongly typed, and you get your compiled with no errors and you can run your code. Then when you run it on the right, if you put in a breakpoint and you look at the stack trace, it's going to look identical, of course, right? There's no other way it could be. Because class A instantiated class B, which instantiated class C, et cetera, et cetera. And it's a big mind shift when you realize that this isn't the way it has to be, right? When you realize that you can actually have some flexibility and you can say, actually at runtime, it might be any number of different ways that it runs. And that's the beauty of using interfaces and abstractions, is that class A doesn't need to know anything about class B. It just references an interface. And same thing with class B, it just knows about some interface as well. At runtime, using your DI container, and this is done for us in the startup of .NET programs, you have to write the code, but there's an entry point for that to happen inside of when you're configuring services. Right now, you can say at runtime, I want class A to actually work with class B, which should actually work with class C, even though at compile time, there's no reference there. And I can easily swap that out now so that, the next time I build the code, it's using something else. I can even make it runtime variable if I really want to by using some reflection in there. So there's ways to do, plug-in architectures where, you don't even have to recompile and redeploy the code to bring in different modules to your system. What this does is make your code way more flexible, right? There's a whole camp of folks that think that this is over-engineering, and will argue that, well, we don't need to have an abstraction for our data access because we're always going to use SQL Server. It's not realistic that we would ever use something else. We're always going to use any framework. We're not going to change that. And the thing is, it's not just a matter of like what is going to happen in production. It's also a question of what are you going to do in your own different environments? What are you going to do in stage? What are you going to do in test or a shared dev environment? What are you going to do in the local machine? What are you going to do when you've got a Docker container that sets this up? How are you going to run this thing if you're completely offline and you want to be able to put in different fake services for some of the dependencies that it uses so it still seems to work, right? All of those things are easy and possible if you have abstractions in place and you can swap in whatever implementation you want for any dependency. Right, those get much more difficult if everything is hard coded to something that has a real dependency, especially if it's an out of process dependency like a database or a set of web services. And it's so easy and cheap to add these abstractions, and it's just the way .NET works now that there's not a lot of reason why you wouldn't do it this way, why you wouldn't go ahead and create abstractions for those dependencies you're going to use. It'll take you 4 lines of code once, and then you'll have the benefit for the rest of the application's life. Right, so at the end of the day, the biggest thing you want to do with your architecture and the decisions that you're making is you want to make it so that the right thing is easy and the wrong thing is hard, right? You want some new developer who joins the team to be able to immediately kind of understand how the system works. And as they start to enhance it and add to it, they are automatically sort of falling into the pit of success and forced to do the right thing. And it's hard for them to do the wrong thing, right? There's guardrails, there's constraints that keep them from doing it. Because if you don't do that, then, if someone's moving fast and breaking things, right, they can easily start to introduce the wrong stuff. And that can have major consequences down the road. This isn't so much a matter of trust or no trust, right? This is a question of everybody's busy. And we want to limit how much you have to think about, right? We use strongly typed languages. Why? So the compiler can tell us whether or not these types are what we expect or not. Why do we use scoping inside of a function versus just using global scope for everything? That's a constraint. If we're really good developers, we shouldn't need that constraint. We should be able to just reason about all those variables. No, we put those there because even experienced and smart developers benefit from not having to think about everything at once, right? And so by putting in some constraints that have to do with the dependencies in our architecture, we make it so that those developers have less to worry about and they can focus on the hard problems and not get tripped up by the simple things. If you don't do this, it's really easy for you to fall into the pit of despair where you have that big ball of mud spaghetti code system where everything is talking to everything and it's really difficult to reason about and test that system. All right, so what are some things that are examples of making the right thing easy? We want to make sure that your UI classes don't directly instantiate and reference things in infrastructure, right? That's not something we're going to be able to easily test, and it's going to add coupling where we don't want it. So how could we structure the solution to achieve this? We want to make sure the business logic doesn't directly depend on that either, right? If we have the business logic depending directly on the database, that makes it really hard for us to swap out the database. It makes it really hard for us to unit test those business classes. And again, how can we enforce this with the solution structure? And are there other ways we can enforce it, right? There are static analysis tools that we could employ that would allow us to do this while having everything in one project if you wanted. But most of those are not free. Most of those are not things that just come out of the box with .NET. And so you'd have to introduce another dependency and teach all your team members how to use it and then add it to your build script and add it to your build pipeline, right? That's a lot of work when out of the box, .NET supports this notion of projects and solutions that gives us the same thing with minimal overhead. You want to make sure that your code is not too full of repetition, right? Anytime you see the same kind of code for the same concept, many different places in your code, that's probably telling you that there's a design pattern or some way that we could extract that out. And we'll talk about that and some things we can do, some patterns we can employ to help with that and how the code organization can help with that as well. And then let's talk about LINQ for a minute. I love LINQ, language integrated query. It's been around in C# for a long time. I don't even remember what version. 2008, maybe it's been there. So, LINQ is something that lets us really easily manipulate data, whether it's in memory or, being translated to SQL using Entity Framework. And the problem with LINQ is because it's so easy and because it's so powerful, you end up with it scattered all over your application. And if you're returning iQueryable from your data context, it can be a problem because you don't even know what the actual data access code is that's going to run because it's been defined in like 3 or 4 different places in the executing code. And so it's hard for you to reason about what the actual query is that's going to execute in that case. So we want to kind of keep our LINQ under control, especially the stuff that's going to translate into actual database queries. And so my preference is to keep all of the iQueryable use of LINQ with regard to Entity Framework inside the data access layer and not build that up throughout the rest of the system inside the controllers and inside the views or Razor pages or wherever else that you might be tempted to use it. So any questions about any of that so far? Principles, patterns, ways to organize things, pit of success, all that stuff. All right, then let's talk about an alternative to so-called clean architecture. Alexa's got a question. All right, so the first time I ever gave a conference talk was back in 2002. Is that right? No, 2001. Sorry, it's been a while. And it was on N-tier architecture. And I actually had this slide in it, which says somewhere, maybe I cut it off. It actually says 2001 somewhere in the original image. Anyway, this is from MSDN, Microsoft's old developer resource, and it kind of shows like how would you do N-tier architecture and N-layer architecture. And the idea here is that maybe your classic ASP that folks were writing in the 90s, and some of us are still maintaining today, looked like this thing on the far left, right? Where you've got some VB script or maybe some JavaScript, and it's talking to the database and it's presenting HTML, and it's just literally intermixed, right? There'd be a, while not record set dot end of file, spit out this row of HTML table, and then add some if statement to say, well, if it's this, format it differently or whatever. And so it was very much spaghetti code for most of the code that folks were writing. Not everybody. And there were folks, I'm sure, that did an excellent job of writing great code, but it lent itself to sort of a intermixed spaghetti code style of writing code. There weren't a lot of modules and things unless you started building COM objects, which is kind of what most of my clients started doing later on. But then ASP.NET came out and everybody was quick to jump on that. Okay, but the idea here is that you'd have the UI layer that talks to the business layer, that talks to the data access layer, that talks to the data source. It looks a lot like this if you break it down. And the problem with this is that all these dependencies are transitive. That means that if A depends on B and B depends on C, then guess what? A depends on C. And so if the data access layer depends on the database, everything depends on the database. And this makes it really hard to do stuff like automation, to do stuff like test-driven development, or even just writing unit tests. I've been there. I've tried to take systems that were architected like this and apply the types of things that you need for modern systems where you want to have continuous integration and continuous deployment, and having everything have to go to the database makes that incredibly painful and slow. And it just sucks the life out of you as a developer trying to make this work. Like, everything is slower than it needs to be. Everything is more painful than it needs to be. And so the solution to this, or at least a solution I've found to be very effective, is to switch to a domain-centric design. And what domain-centric means is that the business logic is the center of the universe. It's the thing everything else depends on. You make sure that it doesn't depend on other stuff, and that will keep you from losing all your hair. It makes sure that you're able to test that very easily because it has no dependencies on anything out of process, and it makes your life just that much easier. So the things that are in this core business logic or your domain model are going to be things like entities, aggregates, value objects, domain events, abstractions for services and data access and things like that. All that stuff lives in this core project or this domain project. And then you create adapters that work with these abstractions to implement all the different things that it needs. So if it needs to send an email, you create an interface for sending email, and then you implement that interface with an adapter that sends email using localhost SMTP. And then you decide, well, we don't want to use that. We want to use SendGrid. Okay, you create another adapter that uses SendGrid. And then in your DI, you pick which one are you going to use, right? Maybe in development, you use localhost. Maybe in production, you use SendGrid, right? And it's really easy for you to swap those out because they're modular, right? And that's what we want. We want it to be modular and easy to change on a per environment basis, not just over time, not just over the life of the app where, on this day we switched from SQL Server to MongoDB or Cosmos DB or whatever it is. No, every day we were able to switch between the dependencies we need in dev versus test versus stage versus prod, and all of it still works, right? Because they all just are adapters for those known abstractions. And then you also want to make sure that your UI is using these same things. So when the app starts up, it's where we wire up all these dependencies. All right, so clean architecture is the name that is given to this approach, the most recent name. And I kind of like it because it's easy to say. Uncle Bob wrote a book on clean architecture, and it kind of covers some of the principles. He goes into a little more detail on things like having a separate project or a separate layer for user stories, which are essentially features. I don't know that that's necessary every time. I don't usually add that as a separate project or a separate layer, but that is, in that book, it is a recommended approach. You will also find blog posts and material on onion architecture, which is essentially the same concept. This is by Jeffrey Palermo. He wrote some blog posts about this back in like 2009, so it's been a minute. You'll also find hexagonal architecture, as well as ports and adapters, which is one of the more clear names for like what it actually is. If we look at onion architecture, this is a diagram, and it gets the name onion because we decided to, Jeffrey decided to arrange this thing as concentric circles with the core of the project being at the center and everything else pointing toward the center, right? So these kind of looks like layers of an onion, as opposed to the classic, stacked view that we would use for dependencies. Ports and adapters, or hexagonal, has diagrams that look like this. The little purple circles there in the middle are the ports. Those are interfaces, right? That's like your, I send email interface, and then you can plug in an adapter for that from the outside that does it a certain way, including fake ones, right? You can use mocks or fakes that don't actually send emails. So, in your demo environment where you don't want to actually send emails to customers, you just plug in a fake email provider and you don't have to worry about it. And so it's really flexible with these different ports that you can plug in whatever adapter makes sense in a given environment. Hexagonal, well, it got the name because somebody decided to draw a hexagon for this diagram. And so, if it had been a trapezoid, we'd have trapezoidal architecture or something instead. But that's where that name comes from, as best as anyone can tell. All right, so some of the rules for clean architecture are that the core of the solution, the centermost project, should hold the domain model and all the business logic, and it should not have any dependencies on external stuff. Right, all the dependencies should point inward toward it, and not from it toward those other things. Excuse me one sec. Okay. The core is where you're going to have all those abstractions. It's where you're going to have the business model. It's going to have entities and value objects and things that kind of reference the model of the problem that you're trying to solve. And all those things have no dependencies on any infrastructure concerns. Then you want to avoid having direct references on the infrastructure project or any of the types that are in it. So, if you put all of your out of process adapters in there, things that talk to a database, things that talk to cloud services, things that talk to file systems or send email, all that stuff can live in this infrastructure project. You don't want to directly reference that from your other projects any more than necessary. The one exception is your application's composition root. This is in an ASP.NET app, this would be program.cs. Now, it is possible to put another project in front that makes it so that all your composition happens in this entry point project, and then ASP.NET Core sits behind that one. And at that point, ASP.NET Core wouldn't have to even know about the infrastructure project. So some people go that far. I don't usually. I usually trust developers to keep the dependencies just in program CS or startup CS if you're on an older version, and not go quite that far. The other thing you can do is make it so that you don't have direct dependency on those types in your startup of your app, but instead use reflection to copy the infrastructure DLLs into the web projects bin folder and then load them with reflection, so you don't have to actually have those types at compile time. So when you actually build in Visual Studio or in the command line, right, it doesn't know anything about those infrastructure types, but at runtime it can load them because the files are there on disk. Okay. Also, if you're going to be writing tests for these adapters, obviously those will need to have reference to that project. Okay, so let's talk about how to organize ASP.NET Core and what goes where. So in the core project, this is where you're going to have your abstractions. That's your interfaces. It's going to be your domain model, which I mentioned. You're going to have domain services. You might have custom exceptions, which is something I strongly recommend, so that instead of having a null reference exception or some generic type exception, have an exception that says, customer not found exception or something like that. And that would be, make it much easier for developers that run into that to know exactly what went wrong instead of just knowing something was null, right? Which is not the most useful thing. If you're using domain events, you'd have your domain events defined here. You would have probably your domain event handlers defined here as well. And then this is where you'd also have specifications defined. And so specifications are a pattern that comes from domain-driven design. And it works really, really well with repositories. And so I mentioned earlier in the talk that, some folks, when they implement repositories, they end up with dozens of the things because every single entity needs to have its own custom repository. If you use specifications with repository, that problem goes away and you don't end up having to do that. So I'll show you how that works when we get to the code. All right, so then here's that. Just pause for a moment so you can kind of see all this. If you're watching the recording, you can pause, but this is it. This is all the stuff that goes in there. Then infrastructure is where you're going to put implementation details, right? So if you're using repositories for your data access and behind those you're using Dapper or Entity Framework or whatever it might be, all that stuff is going to live in infrastructure. If you're talking to other APIs, right? If you're using a web API to talk to GitHub or Twitter or MailChimp or whatever it is, right? Your API clients would live in infrastructure. Any type of file system access, logging adapters that talk to files, talk to databases, all that stuff is out of process. So it all goes in infrastructure. Email or SMS messaging stuff would go here. Anything that's talking to the system clock, you would put the implementation in here. If you are using, datetime.now somewhere just to display or just to store in a record, and there's no logic based on it, then there's no need to abstract it out. But if you have logic that depends on the time of day or the day of the week or something like that, it's a good idea to have an abstraction for that, because then you can write tests that are able to check all the cases at any time. Right. Whereas if you have tests that only work on certain days of the week, right, that's not a very good way to test your application. Other services might live in here, other interfaces might live in here. These would be things that are specific to a particular implementation. So for instance, if you're using AWS or you're using Azure and you are using their SDK and their types, right, and you've got some interface you want to write that, returns back an Azure blob storage thing, right? Well, you don't want that interface to live in core, because now that return type of Azure blob storage is in core, and core would have to have a reference to Azure's SDK at that point, and that's a no-no. So you can put it inside of here, and typically it will only be used inside of infrastructure, right? Some other service will reference it and inject it, but at the end of the day, the thing that is being called from the UI or from core will be a different abstraction or a different interface that's going to be used. All right, in your web project, your ASP.NET Core project, you're going to have all your ASP.NET Core stuff, right? So depending on which flavor of ASP.NET Core you're using, you might have controllers or API endpoints or minimal APIs. You might have views, you might have razor pages. It just depends. You'll have the corresponding DTOs for whatever that stuff is. So you might have view models, API models, binding models, whatever you want to call them. That data that you use to bind to whatever the user is sending you, or to bind to your representation that you're returning back. All those DTOs should live in the web project usually. Sometimes it's good to put them in a different project, but by default, I'll put them in the web project because that's where the view model, that's where the view that it goes with lives, or the API that it's working with lives. And so it makes the most sense to keep it there, at least initially. Other MVC or ASP.NET Core specific stuff like filters or binders, middleware, tag helpers, HTML helpers, all those things would also live in this project by default. There could be other services with their own interfaces. Usually these are services similar to the exception for interfaces where the return types are defined inside this project, right? So if I have a service that is responsible for, getting a whole bunch of information about the order and then representing it and returning it back as an order model, either for me to return back from an API call or to render in a razor page or whatever, right? That DTO lives in web. And so the interface that returns that DTO also is going to live in web. And I'll put that service in here as well. I try to minimize how much business logic is in there. Usually the only thing it's doing is pulling out data and mapping it to that DTO. And that's it, right? So it's very minimal amount of work. Now, you might also, I had a question from Olga asking, what is the advantage of reflection? And I think she's talking about what I mentioned about the web project being able to use reflection to load in infrastructure types. That'll be easier for me to show once I get into the code. But the short answer is that at compile time, there is no reference, if you're using that approach, between the web project and the infrastructure project, which means that if some developer tries to use a type from infrastructure, like a DB context or a SMTP mailer or whatever it might be, inside of the web project, like in a controller or API endpoint, right, it won't build. Right? The only way they'll be able to compile is if they add a reference, a project reference to the project file. And then when you look at that pull request, you're going to see, hey, they're adding a project reference to infrastructure. And you kind of know that that's not what we do. That's not how clean architecture works. And so you would flag that hopefully in a review and say, no, don't do that. But at runtime, it still needs to get to those types. At runtime, it still needs to know how to load those. And so what you could do is check a box in the build that says copy output to folder and say the infrastructure project's output gets copied into the web project's bin folder. And then when the web project starts up, inside of its DI and inside its configure services, it can just load that infrastructure DLL and then find all the types it needs from there. This works best if you're using a third-party DI container like AutoFac. You can put in a registry file inside of infrastructure and then tell AutoFac to load it. And then all the rules about this interface uses this implementation, those are all in the infrastructure project in that registry file, and AutoFac just loads it and wires it all up. So that would be the advantage. Now, you could argue that reflection has some performance hit, but it's only at app startup. And that's how all of the DI stuff works anyway. That's how it's actually already working, is using reflection. So it's not a significant change in the performance versus what you would otherwise be doing. All right. So with that, let's talk about multiple solutions. And what do you do if you want to share code between multiple different applications or solutions? And in domain-driven design, they refer to this type of problem, this type of library, as a shared kernel. And the idea with the shared kernel is that the teams that work on these two different applications or solutions will agree on the stuff they want to share. And it could be 2 teams, it could be 10 teams, however many, but they all agree that this is the shared stuff that we want to have. And then ideally, no breaking changes occur without all the teams agreeing to it, right? Because they're going to have to accept it into their solution. Now, there's a bunch of different ways you can do this. You could just have one giant solution and every team's different apps are all in that same solution, and all the shared code is in some project called common or whatever. And anytime you change it, if it's going to break stuff, it all breaks right now because it's all in one solution. And every time you build it, it checks everything. Now, there's an advantage to knowing right away that you broke stuff. But if one of those teams was trying to ship their code this afternoon and you just broke the world because you changed something in common that was a breaking change, they can't build, so they can't ship, so they're stuck now, right? That's not good. The other approach that folks commonly use is they will have one single source control repository, and then they'll have that common project referenced into multiple solutions. So, there might be 5 different solutions for 5 different applications, but the common folder is still in one place on disk, in one place in source control, still getting pulled into all those solutions. So the problem is the same. Even though you don't have that one giant solution that's a pain to work with, you end up with immediately breaking everybody when you change that common code. So what is the solution? Well, we have package management, we have NuGet. So if you put that common code into a NuGet package, now you can version it, right? So when team A needs that breaking change, they introduce it, they rev the NuGet package up to from 2.0 to 3.0, and they're happy, right? They can start using that breaking change immediately, get their code ready to go. That other team B that was trying to ship right now, they're still on version 2.0 and everything still works, right? They just shipped with version 2.0 and they can take on version 3.0 whenever they feel like it, just like we do with other NuGet dependencies. And so that's the idea. Is you want to have the shared kernel package, ideally make it a NuGet package, have your own internal NuGet feed that you use. It's really easy to set that up. Put in your base abstractions and your base implementations that you're going to use. So a lot of the DDD patterns lend themselves to having a common base value object or entity or whatever base specification, stuff like that. So put all that stuff in this common shared kernel. You might have other things that you want to put in here. If you're using the same DI or the same logging framework everywhere, you could put some of that stuff in here, and other just utilities that you're always using in all your applications would go here. Guard clauses are another common one. If you've got certain guard clauses you use that are custom for your domain, like for your company and how it works, that could make sense. All right, so when you're done, this clean architecture thing that is so over-architected and so complicated, basically is these 3 projects here: web, infrastructure, and core. And optionally, if you have more than one of these solutions, you might also have a shared kernel, which again, I recommend using a NuGet package for. Totally optional, don't necessarily need it. You could just put everything in core and be just fine. If you look at the arrows here, these show the project references that are between these. And so web has a project reference, depends on core, infrastructure does too. Core would depend on shared kernel. Because core depends on shared kernel, you want to be extra sure that you don't put in any dependencies on out of process stuff in the shared kernel, because it's going to now impact every single core of every single solution. What you don't see here is that reference from web to infrastructure that you would need at app startup in order to wire up those dependencies. And that's because you could use reflection for it. But practically, normally, I would just add that project reference too. But it's optional, right? If you want to get really hardcore about this, you don't have to. The other thing you could do, which I mentioned, is you could put a composition root project out in front of this. That's whole job is just to wire up the dependencies. And then it would reference web and infrastructure. And then web would not need to know about infrastructure at all. Right, so that is an option that some folks do. It's not one I typically do, but it would add one more project, but that one project would be like one file, and it would just do the DI composition. What about tests? Well, core is really well suited to unit tests, right? I define unit tests as tests that run only in your code, right? They don't go out of process, they don't go talk to other libraries, they just run your code. And so everything in core doesn't have any dependencies on out of process stuff. So you can run unit tests on everything there. It's great. And they run really fast, right? Unit tests should run in a couple of milliseconds tops, right? They should not take seconds to run. You could write functional tests for the web. That's what I call integration tests that kind of execute the whole pipeline. If you're building APIs, I strongly recommend you write these functional integration tests for your APIs. They're so easy to write in ASP NET Core. It's kind of, you know, a crime not to write them if you're building APIs. So I've got a lot of examples of how to do it and how to do it really easily with as few lines of code as possible. Everything that's in the GitHub sample I'm about to show, well, yeah, you can just kind of steal that code and use it as a starting point, and it makes it really easy to set this up. And then in infrastructure, you'll probably want some integration tests, making sure the stuff actually works, making sure your adapter really does send an email, or really does write to the database and read it back, or whatever it might be, right? You'll want some tests there as well. Unit tests are never enough, but if you can test something with a unit test, it's a good idea to write a unit test for it rather than one of these other more expensive tests. All right, so when you're done, your overall solution might look like this. Again, that shared kernel project should probably be pulled out and made a NuGet package if you want to use it at all. Otherwise, just take those types and just throw them into core and be done. And that's it. So you end up with pretty much 3 real projects that you're going to use, plus the tests. And some of the features that you get from using this approach is this idea of compile time dependency as a policy, right? You have compile time support of this policy about how you're going to do coupling, the direction of that coupling, right? So we want to enforce the dependency inversion principle and say that you can't have high-level stuff that depends on low-level stuff. In fact, we're going to put all the high-level stuff in a project that can't get to the low-level stuff because the low-level stuff project depends on it. And Visual Studio won't let you have a circular reference in your project dependencies. It is framework independent, so you can find the same type of architecture as ports and adapters or clean architecture, whatever you want to call it. It works for Java, it works for Python, it works for Go. It's not just a .NET or a C# thing. It doesn't care about the database. That's one of the key features of it. It doesn't know if there is a database, right? I have a lot of applications where I will go weeks or months without even having a database, building out the application using this architecture, where I can just wire in any kind of stub or any kind of seed data to stand in for a real database until I've nailed down what the functionality looks like. And then I can start to add the overhead of actually creating and seeding and maintaining an actual data store, whatever it might be. And so that's another big feature, is that it's not tied into a database at all. It's very modular. It's really easy for you to have multiple different adapters and use them in different environments as it makes sense. And it's very testable, which means that it's well suited to continuous integration and continuous deployment, where if the build passes all the checks and your team is confident that those checks mean that the code is good, ship it, like automatic, right? You don't have to have somebody waiting. And so you can actually get to continuous deployment. Usually you need to have feature flags, which I didn't mention, but it's another thing you could apply, totally separate from clean architecture, but clean architecture works well with feature flags in order to ship code continuously, even if it's not done, even if it's not ready yet, right? You can have a feature flag that just disables it in production and still be deploying continuously, and then decide to release that feature as a separate decision from when you deploy the software, right? And that's a critical thing that you can get, you know, sort of the pinnacle of your software DevOps capabilities, is when you can say that deploying and releasing are totally separated from one another. Releasing is a business decision and it happens whenever they want. Deploying happens all the time, every time we make a change, and it passes all our tests. That's not to say it doesn't have any drawbacks, right? So let's be honest. Let's talk about some of the drawbacks for this. So clean architecture has a learning curve. You know, you need to kind of understand why are there these different projects and what goes in which one. You need to realize there's going to be a little bit more code than if you just did everything in one class. You could just write a whole application inside program.cs and just use your scroll wheel a whole lot, right? Your scroll finger is going to be like really, really pumped. But it's probably not the best way to organize your code. And so having it in multiple small projects with multiple small files that each do one thing and do it well, to me, makes it easier to organize the code and understand what it's doing. Some folks don't like that. Some folks haven't ever done it that way, and it's a different way of working. So there can be a learning curve in you know, being able to find things when everything references an interface instead of going directly to the implementation, for instance. it's overkill for really simple CRUD applications, right? If you're just doing a demo, if you're just doing a real simple CRUD app where literally there's already a table somewhere and some user just needs to be able to modify the contents of that table and there's no business logic, like they can just delete whatever they want, they can edit whatever they want, just use, you know, some code generator and build that thing in a couple hours, and don't spend a lot of time trying to build a nice architecture and model it and everything else. Now, if that changes and later on it has a bunch of business logic and adds a bunch of features, then yeah, you may want to re-architect it. But initially, you know, for something that's purely CRUD, you may not need clean architecture. It's probably overkill. All right, Adrian has a question. He says, when given the task to convert a spaghettified, I like that word, N-tier project, say a classic ASP.NET MVC4, into a clean architecture one, what would a few good general rules be? Should one start from a code first perspective, identify all the entities, find all the references, encapsulate the way they're changed in various existing services, and build the onion from the inside out, or what? I think what I like to do is vertical slices, which is probably weird to some of you because there's folks that are out there giving presentations about vertical slice architecture. But when I talk about vertical slices, I'm talking about the principle, not the so-called architecture. And let me see if I can pull that up here real quick, just so you can see what I'm talking about. So if you go to deviq.com and search for vertical slice here, there's a good diagram. And the idea is that instead of building things in horizontal layers, like the whole database, the whole data access layer, the whole business layer, like this is your N-tier system, right? And the idea of let's look at all the entities and make them, you know, do the right thing, right? That's basically the business layer, right? You could also say, let's look at all the data access and make it be perfect, right? That's an example of doing it in horizontal layers, right? Whereas doing it in vertical slices looks like this, where, you know, I'm going to change how registration works. And in that, you know, old legacy MVC4 app, I'm going to port that to ASP.NET Core 7, and I'm going to look at the register endpoint or form or whatever it is, and I'm going to build that, right? And then I'm going to add a redirect somewhere that says, hey, when somebody goes to register, instead of going to the old place, they're going to go to get my new place, right? I can put a proxy or reverse proxy like YARP in front of it, and I can route to my new implementation. And then after register, I'll do login. After login, I'll do forgot password, right? I'll just keep on going down and, you know, look at the application and start picking individual pages or individual API endpoints and do them one by one, slicing through the whole system. Now, the first one will be one of the more difficult ones because I'll have to create this structure, right? If I'm doing clean architecture, I'll have to create a core project and infrastructure project and everything else. But after that, it's pretty much just adding to it, and it's just an additive process, and then tweaking the redirect rules so that it goes to the new system. You can also use the strangler vine pattern, which is very similar to what I just described, where you put something in front of it, and initially it just passes everything into the old system, but then you can start replacing the old system with new stuff, and you know, having it route to that new thing. It could be that the new stuff is in a separate project, right? They can be deployed independently, and, you know, everything points to the old one first, and now one by one you start pointing to the new one. It could also be replacing things in place, where you know, everything's talking to the new one, and then you know, break out and fix some part of it in the same solution if you can, in the same deployment. Now, ASP.NET Core isn't necessarily compatible with you know, like web forms or MVC4 in the same project, so I would recommend the two-project approach, and then I would use a proxy like YARP to do that routing between them. But you could also do something with like IIS rewrite rules or some other mechanism to do that splitting. All right. Cool. Hopefully that answered Adrian's question. And so when people talk about vertical slices, not the architecture, like that's the idea of building things and shipping things in user consumable, user valuable pieces, right? These are, you can think of it also as being like feature based development, where I'm gonna ship a feature and not build a layer, right? Because what happens, you know, if this is your structure, and you've got a team and you've got a project and you got a 6-month budget and 6-month deadline to get it done, and you go off and you say, well, let's design the database, right? Because you're database developers and you do everything database first. So you spend, you know, a month or two like kind of building your entity relationship diagrams and making sure you've got all the columns and all the data types are right and all the foreign keys point everywhere, and you got your crow's foot diagrams, your one-to-manys and your many-to-manys, right? And then you got to build your data access layer. So you write a bunch of store procedures and then you build a bunch of code that calls the store procedures and all this. And then, that takes another couple months. And you get the business layer and you add some business logic that talks to those store procedures and those data access methods and the database. And of course, you realize you made some mistakes. So you're having to change the data access layer every time you add a new business service. You're having to change the database every time you do that too. And you end up doing a lot of rework. And then, you start to build the UI and, oh, you ran out of budget. Project's over, right? You didn't actually ship anything useful. And by the time you get to the point where you start to ship stuff, you might realize that you're building the wrong thing, right? As developers, we fail in two ways. We build the thing wrong, or we build the wrong thing. And if we build the wrong thing, that's usually the more expensive problem. So the sooner that you can just immediately ship a vertical slice that goes through everything, right? Your database has exactly one table in it, and it has a data access layer that has one method, and a business layer that has one method in it, right? And a UI that has one screen. Right? And you show it to the user and you say, here's the registration page. Does that look good? Yes, good. Okay, great. Tomorrow we're going to show you the login page. And on Friday, we're going to show you the forgot password page. And then next week, we're going to start showing you the main app, right? That's a much better way to iterate rapidly on delivering software. And if you run out of budget, they still have a mostly working app, right? They have a bunch of features. Everything you ship, they can use, as opposed to if you just have a database schema, like, and maybe some data access code, like the user doesn't care. The user can't use any of that. So don't do that. All right. Hopefully that answered Adrian's question about how I would recommend upgrading from a legacy system to a newer one. And that's what we do all the time with Nimble Pros for our clients, because we have a lot of our clients are on .NET 4.x. They've got 10 or 20 years worth of development on that platform, and they're trying to get to the cloud, or they're trying to get to .NET Core. They've seen the light, they know it's faster, they know it's better, but they got to get there. Right. And at the same time, they've got all their existing customers and people that have, a laundry list of features they want and bugs that need fixed, and their existing team knows how to do all that, but they don't necessarily know .NET Core. They don't necessarily know domain-driven design or how to build stuff for the cloud. And so they talk to me or people on my team to kind of help them bridge that gap and give them the resources or the training that they need to get there. Because it does take some time, right? If you spent 20 years building the system, you're not necessarily going to build a new cloud optimized modern architecture system in 3 months. Right? It's going to take a little while to get there. All right. Now, one thing that can help with this whole clean architecture thing is having a template to start from. And you don't have to use mine. There's a few of them out there. I put one together. Initially, I was just using for my own, for demos and for clients. But I did it open source because most of my stuff is open source so that anybody can use it. And it turns out that some people like it, and it's got a few stars on GitHub. And so to get this template, you just follow the instructions that are right here. .NET new -I will install the template on your local machine. And then you say .NET new clean -arch, give it -o and say acme.solution name, whatever. I said project, but it really ought to be like the solution. It's your namespace that you're going to use. And it will build that for you. So with that, let's do a quick code walkthrough. So I'm going to switch to here and make this even a little bigger. Did you know that Windows Terminal, you can do Control+ and zoom in? That is so awesome. I love that. It's always such a pain otherwise. Let me kill the PowerPoint. I want to go look at that previous slide so I can steal the script there. All right, so we were saying it's .NET .NET new -I Ardalis.clean architecture .template, and this is in the README file. So there it is. I just installed it. Maybe I think it did. Yeah. Okay. Just that installed it. And I'm in a Scratch folder I just created. It has nothing in it. So we're going to say .NET new -o Boston.architecture be our solution name. And did it work? I don't think it works. I think I skipped a step. .NET new, I guess what it is. Clean -arch that -o. There we go. So now it created it. All right, so there we are. So we can go to that and we can just open it up with VS Code or Visual Studio. We'll start with VS Code to kind of look around. And let me, while we're here, you just want to jump right to looking at this, go to Clean Architecture here, and it is github.com/ardalis/clean architecture. I'll throw this in the chat so anyone can find it. And then down here in the README, if you, did I ever update it to 7? It's actually on, yeah, okay, good. It's on 7 now. And what you want is this one, using the .NET CLI template. That's the easiest way to do it. There is also a Visual Studio one that you can install, but it's harder to keep that one up to date, and it's way easier to just do the .NET template. And so this is what gets deployed to NuGet whenever I do updates. Okay, so let's look at what's in here. This is a solution template, not a sample application, but it has a few things in there just to give you an idea of what goes where and set up some patterns that you might find useful. So you'll see it has core, infrastructure, web. It also currently has this shared kernel project in it that has some things like a domain event base or entity base type, right? Things that I'm using in all the other projects. Now, recently, I actually created a shared kernel NuGet package. It's just a public NuGet package, and it's on my to-do list. So by the time you're watching this from a recording, it might not be here to remove this completely. So it won't even be in the solution. So literally, it'll just have these 3 projects. But the shared kernel base types would be then in that NuGet package. Okay, so what's in core? Well, core is where you're going to have your aggregates and your entities. This is not a DDD talk, so I'm not going to spend a lot of time on those patterns, but an aggregate is a collection of related entities, usually like a master detail thing. So if you had an order and a bunch of order items, you could say that order was the aggregate. And when you persist it, you persist the whole thing as a unit. So the order gets persisted with its items. And when you load it with its items. And that's the pattern. That's it. That's the whole thing in a nutshell. And so it makes sense to organize this core project around your aggregates. Typically, that's my preference, right? You don't have to do that. You could have folders for every different type of pattern. Like you could have an entities folder and a services folder and a value objects folder. And I have done that in the past. If you look at some of my older code, you'll see examples of that. But it's good for demos. It's not great for a real application as it gets bigger. In fact, I'm pretty sure that early versions of the Clean Architecture template had that. And so part of the reason why I put in some sort of bogus stuff in here was to be able to show you like, no, we don't want to have a generic folder for, entities. We want to have the actual thing you're building be like right there in your face to say what it is. So in this case, we have this idea of projects, and projects are composed of to-do items, is the kind of basic idea of this sample that's here. And then contributors are people that contribute to these projects, right? And so there's a project aggregate, and it has the project, which is the aggregate root. And so it has an interface that tells the type system that it's an aggregate root. And that comes in useful when we're trying to enforce certain rules, like the fact that we can't grab children of an aggregate directly from the database. We have to go through the aggregate root. So a child of this would be this list of to-do item types, right? So here's to-do item. If I go look at to-do item, it is an entity, right? It inherits from entity base, but it is not an I aggregate root, which means I can't fetch it from the database directly. I have to fetch the project, and then I can get to a particular to-do item from the project. Likewise, contributors have just a contributor on it, and it is an aggregate root. It is perfectly okay to have an aggregate of 1. And you'll have a lot of that in most applications, right? Any kind of lookup data is going to be an aggregate of 1, right? Just an entity that is also the aggregate root. Okay, so you'll see, because this is kind of following DDD practices, most things have private setters. You don't want to necessarily have a lot of public setters in your entities because it makes it so that you're going to end up having logic that operates on your domain model instead of having logic that's encapsulated in your domain model. And so when you change something, it may be that other code cares about that change. And the way that you communicate those types of changes is through events. So for example, if we look at to-do item, right, it has an is done property. And you'll notice the title and description do have setters, right? But if it became important to change that, you could just make those private and add a method. But saying whether or not something is done is a core function of this domain, and there's logic that's tied to that. Maybe we want to send emails to people about that project that was just done, or maybe we need to, notify something or check some business rule or whatever it might be. And so the only way you can change this is to call this mark complete method. And then if it's not already done, we'll mark it as done and also register this domain event. Domain events are a whole other pattern. It's basically the same as UI events, but applied to your business logic. And you can use domain events to decouple things from happening to one another. So if you are listening to your requirements from the customer or stakeholder or whoever, and they say, hey, when this happens, then this should happen, right? If you know about domain events as a pattern, that should be keyed into your head and say, that's an event. That's something I want to use a domain event for 9 times out of 10. Not always, but frequently. So if you're building this to-do system and you've got this idea of projects and projects have items that need completed, and they say, well, when somebody marks an item complete, I want to send an email to the person that owned that item, right? Well, where would you put that logic? You could put it right here inside mark complete, right? We could say, hey, mark it as done. And then, right here, send an email to the owner of this item, right? You could do that, but it would be really nasty, ugly code to do, right? Because right now we don't necessarily know who that person is. Like we've got an ID here for the contributor. So we could go look up who they are from the database. We could add some SQL to go find that user right here. And then we could go and have some way to send them an email. So we could, right here, start writing code to talk to the SMTP server, or we could create some static helper that sends emails and we just drop that right in here. And then later on, we're going to want to write a test for this mark complete. And how are you going to test that? Right now, it's got a database call right in it, and it talks to sending emails right in it as well. And it's really hard at that point when it's that tightly coupled to infrastructure concerns to be able to test that behavior works correctly. By using a domain event, I don't have to do that work right here, right? I can do the simple work of changing the state, enforcing any business rules around the state, and then raising this event, right? A to-do item completed event. And then I can use a handler for that event to say, hey, when an item is completed, I'm going to send an email, right? And here's my email thing. Now this is using an abstraction to send the email. And in this case, it's hard coded. But if I wanted to go and look up the contributor, right, all I would do is inject in a repository or some data access service to go get that contributor and then drop their information right here, right? And that would all happen inside of this handler. And handlers support dependency injection, right? Your entities don't typically support constructor-based dependency injection. And so this is an easy place for us to do that work, and it keeps the logic out of the entity itself, right? All the entity needs to know is that something was marked complete, and it raised an event to say that that was the case. And so it's a great pattern for decoupling stuff in your system. And if you have certain things that kick off really long-running workflows or really complex workflows, and you've got a method that's like 1,000 lines long because of all the stuff it has to do to check all the things, and over the years it keeps getting longer because someone keeps saying, oh yeah, well, when this happens, could you also do this? Could you also do that? Right? And you just see this method growing bigger and bigger and bigger. Right? With domain events, you don't have to do that. Right? You would just create another handler for that same event, or this one could register another event and say, email sent successfully, and then something else could listen for that and respond. And it might be that, sometimes the emails aren't successful, right? So you have another thing that listens for when the email fails. And so it's really easy for you to build a system that uses a lot of small pieces when you do that. Now, the flip side to that is that if some new developer joins your team and they want to see all the logic that happens whenever a to-do item is completed, and they look at this, they don't really see all the logic that happens, right? That they'd have to step through it and see all the different handlers fire to know what happens, right? So there is a flip side, and that is that the logic is distributed to a bunch of small places. Makes it easier to test, makes it easier to add stuff without breaking other things. Does make it harder to reason about it all, when you're trying to learn and see the big picture. So everything's a trade-off, just like I mentioned earlier. All right, then the last pattern I want to talk about here, and then we'll just go into questions, is how I'm using repository. So in this case, I'm using repository from a NuGet package, the base type. And so if we look in data here, you'll see this EF repository. The reason why it's called EF repository is because it's using Entity Framework, right? And so this particular implementation of repository is relying on EF core. But I could implement another version of a repository that doesn't, right? I could have a Dapper one, or I could have a in-memory one, or whatever. And so typically when you name your adapter for a given abstraction, you want to name it based on the specific implementation that you're using. And in this case, I'm using EF, so I'm going to call it an EF repository, and it's going to inherit from this generic repository base and implement these interfaces. And these things come from this ardalis.specification NuGet package. And so if you go pull that down, you can kind of see what all that looks like. But they provide the basic CRUD operations that you would want. But the thing that they do that's really nice is they work with specifications. And so let's talk about specifications for a minute. So inside of the aggregate folder are all the specifications that relate to that aggregate. And so in here, you'll see, like, how do I get a contributor by ID, or how do I get a project by ID with all of its items? Or how do I get, with items by contributor or whatever. Right. And so here's what this looks like. Remember, I was talking about link earlier and saying I love link, but I don't like the fact that link ends up having my data access code just scattered all over the entire solution. And so what this does is lets me put all my link logic inside of this one class inside my domain model. Right. So even though it's link, and it's basically about data access, it lives inside my domain model, not my infrastructure project, because it doesn't know anything about the implementation details. It's just pure C# code. Now, Entity Framework can translate that C# code into SQL because it's an expression tree, and potentially other things could as well. Turns out there's not a whole lot of other ORM tools that can do that. EF is kind of unique that way. But there's nothing to say that you couldn't look at this expression tree yourself and create your own, dapper where clause out of it or whatever. The point is that this is a pure C# thing that does not directly tie itself to Entity Framework or any other implementation, even though in practice it works best with Entity Framework. And so you can create these specifications. They have a custom name, right? So you can say exactly what it is. It makes it really easy for you to reuse. If you're a developer and you need to fetch, a project, and you need to get it with certain parameters, or you need to have certain relationships, it should be pretty easy for you to find one of these that already exists, or find one that's close and then modify it to suit your needs, right? None of these are big, and they support features like caching and building cache keys and things like that, in addition to all the other link stuff that you might expect. So because we're using specifications, that's why I don't need to have a whole bunch of different repositories here, right? There is not a project repository. There is not a contributor repository. There is just this one repository. And so another thing that I hear people talk about when they're saying why they don't like clean architecture is because when they go to add a feature, they'll throw up another straw man argument, and they'll say, okay, that's great. I've got this clean architecture. It's got all these projects, and I want to go into the web project here, and I want to add a new endpoint that lets me do something with a project, right? I've already got list. Now I want to add list incomplete. Right? Let's say this didn't exist yet. Okay, so I've got to touch all these different projects now to do this. I've got to go create something in a data access project. I've got to go create something in core, et cetera, et cetera. And most of the time that's not true, right? It's very rare that you'd have to touch things in multiple places. So yeah, if you want to add another endpoint, and actually this will be prettier in Visual Studio. So let me just jump to Visual Studio real quick for this part. Open project and go to Sketch. The endpoints have this convention that Visual Studio supports of chaining the files, just like Razor Pages and other things do. And so when you look at these API endpoints here, you don't see all those other files like you do in VS Code. They are here if you need them, right? These are the DTOs. This is following the Reaper pattern, request endpoint response. And so here's the request, and here's what the request has as a DTO. And then here's the response, and it has these things in its DTO. And then here's the endpoint. So when you're working on an endpoint, everything you need is right here, all chained together. And if you are creating this thing brand new, the one thing you might need to add is a way to get all the incomplete items, right? And so that might be in a service, or it might be if you're just using a repository directly, you might have to create a specification for that. And then that specification is reusable at that point, from that point forward. You would not have to create another repository, right? You would not have to touch anything in infrastructure at all, unless you were creating some new dependency, right? Like, I've got an SMTP email sender. If you have a requirement that says, hey, we're going to use SendGrid, then yeah, you're going to have to write a SendGrid adapter for this email sender interface and drop that in infrastructure. But for any given feature that you add to the system, you probably very rarely need to touch the infrastructure project. And so mainly you're going to be working in your domain model and adding something to an existing aggregate or creating a new aggregate. And then you're going to be working in the UI here, creating a new endpoint or creating a new page or whatever it might be. But generally just those two places, the business logic and the UI front end. The data access is pretty much taken care of for you where the only thing you've got to play with is making sure you've got the appropriate specification to get the data that you need. And then if you're using any framework, once you make whatever changes to the model, you just call save changes and it does its job, right? That's its value add, is that it does the change tracking for you. Incidentally, while I'm thinking of it, that change tracking and the way EF does persistence is also how my domain events are being implemented in this template. So if you look at the DB context here, you'll see that we're overriding save changes async. And inside of save changes, it's going to go find any entities that have events that it's tracking. And so when I said register this event, what it did was it added it to a collection of events on that entity. And so then I can go in here and I can say, hey, do they have any domain events? If they do, then go ahead and dispatch them. And that's what wires that up. That's how those domain events work. It's probably a good time for us to actually run this thing and verify it works. So just control F5 and see that it works. Remember, I just did this with a .NET New a second ago. So this is running the actual template that you would get. And so here it is. It's got some information on how to use it. I usually like to use the API Swagger thing to take a look at it. And so you could do something like mark something complete. So we could say, let's go get a list of items. So let me get, let's just get a project by ID. So get project ID, try it out. Number one, I probably should use Postman for this, but this will do. So here's all our projects. You see none of them are done. They all say is done, false. So we can mark one complete. Now this is going to fire off a domain event, and that domain event is going to have a handler that's going to try and send an email, and we don't have a way to send emails right now. So we're going to see a failure on that. So we're going to execute this. Or maybe not. Maybe I don't have it wired up. It says it worked. All right. So it's great when your demo is supposed to fail and it doesn't. But we run this and we say, okay, that worked. It set it to true. Do I have an email thing running that I didn't know about? Let me just double check what's wired up in startup. So in program.cs, when, oh, you know what? It's not in there. Let's go to the interface itself, our email sender, and find all the references. And then in default infrastructure module, we're going to do this registration, and I'm in debug, and that's why. So development only says use the fake email sender. Otherwise, it'll use the SMTP for production. So if I switch this to release mode and run it again, I think that will make this one work as production. We'll see in a second. Meanwhile, if anyone has any questions, let me know. Let's see, I think now it's running in release mode theoretically, and we can try and do this again with this patch endpoint. We'll try and make number 2, and it's going to still work. Yeah, okay, fine. So let's do this, and let's see. We're going to say no matter what, we're going to use the SMTP mail sender for that one too. Email sender. I want to show you how the SMTP stuff works. So run this one more time. And then just do this thing, try it out. Project 1, item 3, execute. Now it's hanging. Now it's trying to talk to SMTP and it's going to blow up. Maybe. Yeah, here we go. And so we get this error that says failure sending mail because I couldn't make a connection. And so there's some really nice tools that you can use, like SMTP for dev, which is a local SMTP server that you can install. There's another one called Papercut, which I like. It's a little bit nicer. And Papercut is a email thing, SMTP server, let's say. So there's Papercut SMTP, same idea. Now, the really cool thing is if you're using Docker, you can run this thing from Docker with a single line of code. And so in here, you can literally just copy this line right here and go into your Windows and run this. If you have Docker running, which hopefully I do, maybe I don't. Why do I not have Docker running? Let's see if I can start Docker. And this will let you do that. Let's see if we can get Docker to start. But alternately, oh, there it goes. Alternately, you can use SMTP for dev, which you can just run. So like in my Dropbox, I have a bunch of utilities, and one of them is SMTP for dev. And so it's just an exe, like this, SMTP for dev.exe. Put it in your Dropbox utilities folder if you do that. Run that, and sure, it will try and access your firewall and whatever, but here it looks like this. Okay. And I need to now, let's see, I need to get my system back into a state where the stuff can be modified and basically receive the database. So I'm going to exit my application. Yes. And everything is using SQLite. So I'm going to delete SQLite there. And then we may as well just be in debug at this point. So I want to debug anyway. And we'll hit Control F5. And that should bring us back to over here. All right, so let's verify if I do give me project 1 again, try it out. Here's project 1, execute. It should say false, false, false. It does. Okay, so now I can go in here and I can say, let's mark number 1 complete and execute. And it says it was good, right? And if you look at SMTP for dev, you see we just got an email at 7:31 p.m. on February 15th that says get sample working was completed. So it worked. All right, we can also step through that, obviously. So we can come in here and we can go find that endpoint, which is a controller for project, maybe. So I have a few different ways to do it, and maybe it's this one, project controller. There we go. So when you use this template, you're going to pick one way of doing things. Ideally, you're going to be building ASP NET Core with controller-based APIs, or with minimal APIs, or with fast endpoints, or my API endpoints, or views, or razor pages, right? You're going to pick one of those things. It has all of them, because maintaining 6 different ones is going to be really a pain in the hind end. So delete all the ones you don't want, right? If you're not using MVC views, you can delete the view folder, the view models folder. If you're not using razor pages, delete the pages folder, right? And so initially it's got a fair number of different options in here, but most of them you're going to throw away and just keep the one that you're using. In this case, I have an API controller for doing that thing that we've been doing. So I'm going to put a breakpoint right here. And this is that specification where I'm loading up that project by ID with items specification to do that. And so let's see, we'll hit F5 this time. And we'll be able to see how it actually steps through all the events and everything for this to work. And then we'll see if there's any questions. So let's come back into the API documentation, and we'll go down here and hit this patch, and we'll hit project 1, item 2, and execute. And we should hit our breakpoint. Maybe it did. No, it did. Okay, just didn't bring it focus. All right, so we're in here and we've got this thing, and our project ID is 1, and we can step over the spec, and we can step into here if we want, and we can see there's our items and create our project. And this is happening from external code, create all our individual things. All right, if we didn't find the project, we'd say not found. If we didn't find the item we were trying to do, we'd say not found. Otherwise, we're going to call mark complete. So let's step into our domain model now. So now we're in core. This is all our domain logic. We're in mark complete. Is done is currently false. So we're going to say if it's not done, mark it to true. Register a domain event. That's in the base class. So if we go look at that base class, it's going to create the completed event, which is just passing in a reference of the item. And then inside that register, it's going to go here, and it's just saying domain events.add, right? So currently domain events is a collection that's private inside the entity, doesn't have any events yet. So we just created this entity. So we're going to add one to it. And so now it has one domain event. And so if we look at this and we go look at its domain events, you see there's one event right there. And it is a to-do item completed event. Okay, so then the next thing that's going to happen is we're going to save this thing. So we're going to say repository update. So we get into there, come in here, and it hits save changes async. We actually do save it. So here's our int result. It says 2 rows were changed. So the aggregate, both the project and the to-do item were changed. And then if there is a dispatcher, we're going to dispatch the event. So we're going to go say, give me all the things that have events, which is this one entity. And we'll step in here to dispatch that, and we're going to use mediator here to publish that domain event. So in here it says, go find me all the entities, go find me all the events, clear them out. So now they're not there anymore. And then for each one of those events, go ahead and publish it. And then this is what will actually end up hitting, using some reflection, our sender here. So I think I skipped over it, but it goes to the handler that's going to end up sending the email. So then in here, we create the SMT mail. Oh, I know it had to create it first. Now it goes to the handler. It had to create it because it has to inject it here, right? So right here, it just created an instance of SMTP mail to inject. And now here it is, right? And then resolves that. And we're inside of here, and this is where it's going to send the email. We can step over that. And as soon as we do, we come over here and we should see this show up as another one. I'm not sure why it's not there yet. Let's just continue and done. And there it showed up. Boom. All right. So that's how that works. And yeah, so William has to drop, says he's learned a lot, even though he's been doing this in the last 6 months. Cool. And Olga's been adding links to things, so I appreciate that, Olga. Thank you. Yeah, there's a link on DevIQ for the Reaper design pattern, if you're interested in that. And I did promise to look at eShop on web also, so let me do that real quick while I listen if there's any questions. So if you just Google eShop on web, you'll find it. If you want to ask any questions, just come off mute and go ahead and ask.
I think
Yeah.
you wanted to show us integration tests, how easy that was, right?
Yeah, I want to do that too. That's in both of these projects. Let's do that in eShop on web just because I'm here. Another quick tip that some of you may not know, if you go into GitHub and you want to find something in a GitHub project, right? Let's say I want to find the integration tests. All right, well, there's a test folder that sounds good. Okay, maybe it's in functional tests. And you do potentially have this tree view sometimes, which is nice. But if you're in like this type of thing where you're just seeing a folder at a time, it's kind of tedious to have to navigate through all this, right? And so what you may not know that is really nice is if you just hit the period key, the dot key on your keyboard, it will actually launch github.dev, which is VS Code in your browser. And so in here, it's literally VS Code, like it'll show you the release notes of VS Code. But now you're in VS Code for real inside the system. You can use search. Yeah, you have plugins and extensions. You have all the stuff you might have with Visual Studio in the browser for GitHub. So it's really amazing. So if I wanted to show you, like I mentioned, the directory packages props, right? Like here's what this looks like. And it's got, color coding, and you can see it's got its custom icon and everything here. But this is where I put all the versions for all the dependencies. And when you set this up and you set this flag right here to say manage true, it'll make it so that it'll actually throw an exception on the build. Not an exception. It'll have a build error when you set the version inside of a project. So if I look at this public API project, there's a CS proj right here. Notice all these package references don't have a version, right? If I add a version to them accidentally, it'll break the build. And that's because all these things are getting their version from this directory packages props file. And so this saves you a lot of trouble keeping all your dependencies up to date. Okay, so a couple quick tips there, but now let's look at those tests. So in here, we've got functional tests. Let's look at an API test for, oh wait, I forgot. These ones are mostly commented out. Let's try this one. I gotta fix those. Okay, so here's one that's hitting the catalog controller and it says, hey, I should just return the home page with a product listing. And so this one is really simple. It's not even hitting an API. It's hitting a page that returns a view. And so it says, go get me the home page. Ensure success status code, give me the entire response as a string, and then verify it contains this code. All right, so it's a pretty simple one. Similarly with orders, you can go fetch my orders and verify that it has a link to the login page if you're not logged in. And so like for the anonymous user, we expect it to redirect to the login page. Right, we can verify that the status code that we got back was in fact a redirect status code. Let's see, I don't think we have as many tests over here as I thought we did. So let me switch back over to this one.
Just really quickly, sorry, what if I'm on Mac and I'm on GitHub, what do I press? Which
I thought it would be dot. I haven't tried this on
dot?
Mac. Yeah, just dot from github.com/some repo.
I think
And if you want to, if
one
you want to get,
constraint there is you have to be signed in. If you're not signed in, it won't work.
yeah, you have to be authenticated. That's right. And then if you want to get back to GitHub because you want to see issues and pull requests and everything else, right? You have to come in here, click the hamburger icon, and then just say go to repository, and then you're back where you started. And you can see all the usual stuff.
Okay, so just one quick, don't be on the URL at the top of the browser. That's why it would add.
Oh,
dot
you were
for me.
here and you
Yeah,
said dot. Yeah, that
right.
one.
Yeah,
No,
so yeah,
yeah,
don't do
just
that.
click somewhere on the page, and then while you're somewhere in the page, hit dot, and it'll switch it. All right. Let me show you some better tests than what are in eShop on web. I guess I need to go add some better tests to eShop on web. So in here, let's look at API endpoints for like, get project by ID. And it wants to return the seeded project. If you say I want number 1, right? And so here's the code that goes and gets the actual response. And so I'm using a helper here. This is a extension method that I wrote that says go get and deserialize this endpoint. And so I'm also using a helper here to build the route, right? So one of the things when you're writing tests, you want to make sure your tests are like real code, right? You don't want a lot of repetition in them. You don't want to copy paste all the routes everywhere. And then when you change your route, you break, 100 tests that all depended on the old route. Right? Create a tool or an extension method or a helper that builds the route and then use that. So this get project by ID request.build route, if we go look at this thing, peak definition, does that work? I never use it. I guess we'll do go to definition. Cannot navigate. All right. Well, I guess we won't look at it. It must be somewhere. Where are you? There we go. So this build route right here, it's just this angle function. It says route.replace project ID with whatever project ID I passed it in. And then here's the string that is the route, whack projects, whack project ID. And so this route here is actually used by the endpoint, right? So when I look at the endpoint and I say, well, what is my route? It's get project ID request.route right there. And I'm using the same route variable in the test. So if I change this route in here and I say, well, actually, I want it to be, projects 2 as my route. Well, the test is going to update automatically to that, right? So it's a good way to make sure your tests are in sync with your actual production code. So now in here, that's how we got the route. Then this is the response that comes back. So that's the, again, that Reaper pattern, REPR. The response is this DTO right here, get project by ID response, and that includes, the ID and the name and the items. And it's strongly typed. So when I say get by ID and this var result, it is strongly typed as a get project by ID response. So I can just make assertions directly on it. And I can verify that the name that I get back is actually the one that is in the seed data, right? And so there's no magic strings here. If I change the seed data and I give it some other project name, the test still passes because the test doesn't care that it's a particular name. It cares that it's whatever name is the one that's in the seed data. And so that's how you make sure your tests don't break all the time for stupid reasons, right? Keep them from being too brittle. We also want to test the non-happy path, right? This is the happy path. When I ask for something that really should be there, it gives it back to me. What if I ask for something that isn't going to be there, like an ID of 0? I never expect there to be an ID of 0. I expect to get back a not found. Then again, there's a helper right here that just says get and ensure that it's not found, right? And that's the helper method to do that is in this Ardalis HB client test extensions NuGet package that has all those helpers, right? So again, if you grab this template, you'll see all these examples of how to do API tests. Most of them are like 2 or 3 lines of code long. So there's no reason why you wouldn't write these API tests for most of your web APIs because they're so simple to write. They're so tiny and they're really valuable, right? They will tell you right away if something isn't working right. All right. Olga's saying that the biggest pain for tests is creating the test data. Yeah, that's definitely a pain. You can use something like this where you just have a seed data class and put whatever seed data you want in there. And then in my case, I'm using that because this is a template just to have something to show when you hit F5. In a production application, I would probably still have seed data, but I might put it inside of the test folder or a test project rather than in production because I wouldn't use it in production. I'd only use it in the test in many cases. Sometimes I'll use it in production. Not in production, but in the actual code, because a new developer that hits F5 on their local machine wants to see some data too. So it may make sense even in a real application to still have some seed data there in the main app. So It's not to say I would never do that in a real application, but it's definitely very useful in this case because it's just a template that I'm using. All right, that's most of what I had for tonight. Happy to look at more code, answer questions. Again, this is a monolithic approach. So if you were just building a project with ASP.NET Core, you could structure it this way, and you would have one solution with the 3 projects, move shade kernel to a NuGet package, and be done. If you're building a distributed system and you're using microservices, let's say, there is no reason why this wouldn't work for a microservice. And then other microservices would also follow the same structure. Now that assumes that your microservices have some complexity to them and some business logic. If they don't, then the question is, why are you using microservices? And if in that case, you probably don't need microservices and you probably don't need clean architecture. But if there's complexity there, enough so that you think that it warrants having microservices in the first place, then it probably also warrants building it in a testable manner, which this particular architecture really helps with. Let me throw up a couple resources here. Yeah, that'll do. That's pretty much the same stuff I showed at the beginning, I think. So yeah, if you're watching the recording, you can hit pause and see this. But that's, I think, all I've got. Yeah. And so other than that, we can just spend whatever time is left answering any questions about eShop on web or the clean architecture template. Anybody?
Yeah, can you show how did you do the seed data? Like,
yeah. So you can grab this yourself, run the same command I ran, and have it all locally. But this is a static class called seed data, so I can get to anything on here statically, right? And so if I want to know in a test, what is to do item 1, and I want to verify that it's what I got back from an API call, I can just look for seed data dot to do item 1, and then get to these values to check and compare. When I go to create the seed data is when the app starts. So in program CS, somewhere in here, it's going to actually add the seed data, which is right here. And so you have to create a scope because Entity Framework requires a scope, and I'm using Entity Framework in this case. And I say context.ensure created, that creates the database. Again, for local development, I'm just using SQLite. So you'll see this file database.SQLite right here. Anytime you want to start over, you can just delete that file and then it'll recreate it when you start the app. And then seeddata.initialize is the method that does the work of actually adding things. So we can go to its implementation, and it basically just calls populate test data. And then each one of these just says, remove whatever's there and then add these things, right? And it's pretty small because this isn't meant to be a full sample app. It's just, again, meant to be a template. So it's just got, one project with 3 items and like 3 different contributors or whatever. And that's about it, right? But it could grow arbitrarily large if you wanted it to. If you had a lot more data for your application. Does that help?
yep. So each time you delete and add to your local SQLite database.
Yep. And if I wanted to, I could, right before this ensure created, I could just delete this file, and that would do the same thing to reset it, right? SQLite's nice because it's so fast, right? So if I delete it, which will only let me do if I don't have anything referencing it, then I can just run it again, and as it starts up, we'll see that file will show up here again. There it is, right? And so while it's running, it's got these other files with it, and then now you've got the data, right? And so
right, and for those who are not lazy, you can put it in a JSON files as well.
Yeah. So you could put the seed data in JSON, you could put the seed data in JSON and then read the JSON and then put it into the database. There's all kinds of different ways you could do it. Maybe you don't want to hard code it like I'm doing here. Where's here? Like I'm doing inside seed data, right? Like these strings, maybe you don't want these hard coded in your code. So you could put that in a JSON file like you're saying. Other questions?
Yeah, when you were demonstrating the email and the domain events, I noticed that, something was persisting to the database, and then it went and created the domain events and dispatched them.
Right.
Looked like there was maybe potential to, some kind of error would not dispatch those events, and you'd have something persisted to the database that other things wouldn't hear about? Is that just because it's a demo app, or like how would you handle like,
No, that is possible.
okay,
I talk about there's two types of domain events. There's pre-persistence and post-persistence. And that's not exactly what you're asking, but let me cover it real quick first. So it is possible to have domain events that fire off immediately when you raise them. And so imagine that in here, inside of to-do item here, when I say register domain event, right there, it would jump to the handler and it would send the email, right? And so that is a pattern that you can use, and I've used that in the past on different systems. And you can combine the two. You could have some domain events that are immediate, and you could have other domain events that happen after persistence. I tend today to only use the post-persistence domain events because I never want to be in a situation where I sent the customer an email telling them thanks for your order, and then when I went to save it, the database failed, right? So it is possible that the save could complete in this example right here. Right, this int result is going to be some non-zero value if the save was successful, but then there might be some error here where it doesn't happen, right? Or there could be multiple different handlers, and one of those handlers has an exception, and it blows up, and none of the rest of them happen. So that could happen too. Like, you know, you could add try catch logic around this. I would probably just put that in the dispatcher. That's up to you whether or not you want that. But I would rather store the state and not fire off the event than the other way around, fire off the event and potentially send an email out of process, and then not store the state and not know, as far as the system's concerned, it never happened. But yeah, it is basically that it's a demo app that there's nothing here to deal with that. There's no retry logic. There's no anything. So for a real application, you'd want to be able to monitor what happened. You'd want to log that the things happened. You'd want to be able to retry them if you needed to. All that stuff is sort of left as an exercise for the user.
right, got it.
Let's see, Derek is asking, are there benefits of AutoFac over the out-of-the-box DI system? Sure. So in program.cs, up here at the very top, I am saying here, the built-in system, add DB context, add controllers, add razor page. This is all vanilla ASP NET Core stuff, right? And then somewhere in here, I'm adding AutoFac. Where is it? Why am I not seeing it? There's AutoFac right there. Let's see if I get rid of AutoFac, that should tell me where I'm using it. Oh, it's right here. Okay, cool. So use provider factory AutoFac service, right? Okay, so what does AutoFac do for me? Why am I bothering to use it? Especially since you can see here, I'm just using all the built-in stuff for the DI. The main thing that I use AutoFac for is two things. One, it's really nice for decorators. So if you use the decorator design pattern, it's really easy to use decorators with AutoFac. It's kind of a pain to do the same thing in the built-in DI system. You have to kind of do it all yourself, and it takes like 4 or 5 lines of code to do, and it's just ugly looking. So AutoFac has really elegant support if you just want to add decorators to something. For example, it's not right here, but imagine that in here I had some code that said, builder.services.add scoped of iRepository, and it's generic, so it would have to be type of iRepository of something, and then comma type of EF repository of thing. I wanted that like that there, right? So imagine I had this code, right? Now I want to add caching. Right, it's really easy for me to use a cached repository pattern and decorate this with a cached version of it, where all the caching logic is in the cached repository type. And then internally, it would use the EF repository, so it would wrap it. So you'd have, on the outside, you'd have caching, on the inside, you'd have the entity framework implementation. Maybe I want to do logging on that too. Well, instead of going in and having to add log statements to all the things in here, I could have a logging decorator that would be on the outside, and then I'd have caching inside of that, and then I'd have EF inside of that. So these cross-cutting concerns work really well with the decorator pattern. And it's kind of a pain to do decorators using builder.services. It's really easy to do it with AutoFac. So the other thing AutoFac lets you do is create these modules. I think I called them registries earlier, but they're called modules here. So there's this AutoFac module, and you can put the module in the project that has all the types, right? And so I don't have to put all the references to, EF repository like this inside of program.cs and make program.cs super long with every service I might ever need. Instead, I can just have all the things that are in infrastructure be in here, right? And similarly, inside of core, right? There's not a whole lot of stuff in core, but these two services that I want to set up, I just set them up here in core, closer to where they are defined. And then when the app starts, it will load this module and be able to find this code and do the registration that way. I don't think I have an example of a decorator setup here, but if I did, it would be something like builder.register decorator of, type of, well, I guess it'd be, I don't know, I don't have it, but if I had a cache repository, it'd be something like that. And then, off of that, you could say dots, around or over or whatever, this one here, right? And I could say, I want this one to decorate this one. And it's pretty straightforward to do. I don't think I have an example of it here, but if you Google it, you'll see it real quick. Yeah, so those are the two main things that I end up doing fairly frequently, is having the modules so that the dependency registration is closer to where the things live, and then decorator support when I need it. You're welcome. Anything else? Thanks, Olga.
Yeah, great presentation. Great. Good job.
Thank you.
And it's good that you have done it before. I think you know it by heart now.
Yeah, I've done it a couple times. Yes. All right, Robert, back to you.
Yeah, no, thank you, Steve. Really, really appreciate it. Thank you, everyone, for joining us tonight. I'm just going to close the presentation or the